Hi everyone, my name is Kaitlin Farr and I'm a software developer at the Johns Hopkins Applied Physics Lab. I've been developing upstream for OpenStack for 3 years and I'm a core developer on Barbican. And today I want to talk to you about flexible key management for your projects. So to give you a general idea about how key management is used for public key infrastructure, PKI systems, I'll go over a use case. For example, a user may want to generate a certificate. So the first step in that is to generate a key pair, a public key and a private key. And these keys may be stored in the key manager. The user may either generate them locally and store them in the key manager or request that the key manager generate them for him. So from here, the user will take his public key and use that to generate a certificate signing request and send that off to the CA. And then it's the CA, the certificate authority's responsibility to issue the certificate. And then it will send it back to the user. So from here, the user has the certificate. So in this scenario, the key manager was used only for storing the objects, and it was the CA's sole responsibility to issue or revoke certificates. A key manager is useful because it provides a centralized location to store your keys. It may provide logging, audit logging, to show who is accessing which keys, and it also provides an alternate means of accessing your keys rather than emailing them around. So in an OpenStack perspective, there's a few security features that already use key management. One is volume encryption. And for this, Cinder, the block storage service, will request that the key manager creates keys when it creates volumes, and then Nova will retrieve those keys when Nova attaches the volume. For ephemeral disk encryption, Nova will request that the key manager creates the keys and will retrieve the keys while it's booting the instance. For glance image signing, the user will generate a certificate and store that in the key manager. And then Glance and Nova will retrieve that certificate and use it to validate that the image hasn't been tampered with. And there are many other services and projects that use key management in OpenStack. For example, there's Sahara, the MapReduce service, which will use the key manager to store passwords that are specific to the MapReduce program. There's Swift, which uses object encryption, and Swift will store the keys in the key manager for storing the objects at rest encrypted. And so in all of these services, there was a pattern of generic boilerplate key manager code that was being implemented, and so it made sense to pull out that boilerplate code and put it into a separate library. And so this is where Castellan comes in. Castellan was just that boilerplate code extracted out into its own library. It provides a generic key manager interface. And so as I mentioned before, certificate authorities are responsible for generating and revoking certificates, but the key manager can store, retrieve, and delete all sorts of managed objects, whether it's public, private, symmetric keys, passphrases, opaque objects, and certificates. It can also generate the keys as well, public, private, or symmetric, as that's already part of its cryptographic abilities. And so Castellan includes many configurable backends, including Barbican. So at this point, you may ask me, what's the difference between Barbican and Castellan? And Castellan is just a generic key manager library that you can import into your project, and it will allow you access to several backends, one of which is Barbican. And so it expects that Barbican will be run as a separate service. So as I mentioned, Castellan is an OpenStack specific project, so you can specify the Castellan options in your Oslo config file. And so those are passed on to Castellan, and you can specify which backend you want from there. By default, it will take Oslo context objects, but you can also specify whether you want it to take keystone tokens or username and passwords. And it could also possibly be extended to support other authentication methods. But this configuration is dependent on the operator to make sure that it's compatible with the respective backend. So as I mentioned earlier, there are several backends that are available, one of which is Barbican. And Barbican itself, as it's stood up as a separate service, has different available secret stores, one of which is like a simple database backend, another is DogTag, another is the Key Management Interoperability Protocol, KMIP. And so these will use hardware servers as a backend for storing the keys. As I mentioned before, for the boilerplate code, many of the services implemented mock key managers to make unit testing more easy when you're testing the encryption features. And so Castellan includes a mock key manager backend. Depending on your policy for deploying your cloud, you may need to talk directly to a FIPS compliant hardware server. So in this case, it would be possible to implement a Castellan backend that would talk directly to the KMIP enabled server. And KMIP is just a protocol that's governed by OASIS. And this backend does not exist yet, but it's a possibility that it could in the future. So if you noticed on the list earlier for Barbican, KMIP was already supported backend for Barbican. And this backend uses a library called PyKMIP. And PyKMIP is a Python library that writes the bytes on the wire in the proper order that a KMIP-enabled server could read them. PyKMIP also includes a software server that will allow you to test to see if your operations would work against an actual hardware server. The software server is not supported for an actual deployment environment, but it's just good for testing. So the goal of Castellan is to make a wide variety of backends that would be good for deployment. So if you have any ideas or any needs for key management in your project that could benefit from a different backend, please feel free to submit it for review on Garrett. There's also a bug report page where if you find any bugs, you can report them. Additionally, currently, the only way to interact with Castellan is through the Python interpreter as an imported project. But you can also, there is a work in progress to create a Horizon plugin for Castellan so that through Horizon you could list certificates, you could request to create keys or view keys, and so on. So that's all I have. Thank you very much.